guys, so we're going to continue with angles, and we're going to talk about inscribed angles. So we've talked about central angles before. And your central angle, just as a reminder, is where the vertex is going to be right there at the center, okay? And then if this arc is 80 degrees, the central angle is 80 degrees, and vice versa, all right? So now what we're going to do is we're going to talk about inscribed angles. And an inscribed angle is an angle whose vertex is on the circle, okay? And the sides contain chords. So the sides are going to be chords, basically, and your vertex is on, as opposed to the center. This is where you're going to have to keep your head straight, okay? So angle DEF is going to be an inscribed angle. That's what you would call it. And then intercepted arc is basically going to be the arc that shares the endpoints with the end of the angle, okay? So it consists of endpoints that lie on the sides of an inscribed angle and then all points in between them. So angle arc DF is an intercepted arc, okay? And then you also have this terminology here. This is really going to come into play in a couple days. A chord or an arc subtends an angle if its endpoints lie on the sides of the angle, okay? So this arc right here subtends, arc DF subtends angle DEF because of the fact that the endpoints lie on the sides of the angle, okay? So it's basically this piece that you're looking at when you're looking at your inscribed angle, okay? Here's your inscribed angle theorem, guys. The measure of angle ABC, the measure of an inscribed angle is going to be half the arc. So if this arc is 80 degrees, this is going to be 40 degrees. So that's different than our central angle because the central angle, it would be the same measurement. It's going to be half. And you can think about it like that. Well, this looks like it's bigger than this angle right here. So that can help you remember it. It doesn't matter if it's going through the center, if it is going around the center, or if it has nothing to do with the center. It's still going to be the same formula, the same theorem. And then the corollary goes along with that, which we'll see in just a second, okay? So we want to find the measure of angle RST. So we want to find the measure of this angle here. It's intercepting arc 120 degrees, so we're going to cut 120 degrees in half. And we get 60 degrees for the measure of that angle, all right? And then going backwards, we want to find the measure of arc SU, okay? So we want to find SU here. So let's zero in on the angle that intercepts it. This is 40 degrees. The arc is going to be twice that. So your answer is going to be 80 degrees. Like I told you guys, it's not hard. It's a matter of remembering all these theorems, all these rules. Alrighty? This corollary goes along with it, guys. It basically says that if different angles have different endpoints, if they still subtend the same arc, then they're going to have the same measure. So for example, angle ACB and angle ADB, and of course angle AEB, they all are subtended by this arc AB. Well, if this is 80 degrees, this is going to be 40, this is going to be 40, this is going to be 40. It doesn't really matter where it ends, as long as it's inscribed and it has the same endpoints. Okay, so it kind of opens up to the measure that it's going to correspond with. All right, so let's look at this one here. So we just have to do a little bit of digging. So I want to find the measure of angle DEC. All right, so this is what we're looking for right here. And then we have the measure of arc AD is 86. So this arc right here is 86 degrees. So my strategy is, and this isn't necessarily the only way to do this problem, okay? My strategy is, if I go through and I find these angle measures, then these are going to be vertical angles here, all right? Well, this is 86 degrees. Then we can go through and we can say this measurement right here is going to be half that. So that's going to be 43 degrees. Okay, well, if I end up doing 180 minus 60 minus 43, I'm going to get this measurement right here, which is going to be 77 degrees. Okay, well, based on my vertical angles theorem, I know that angle DEC also has to be 77 degrees. Okay, so that isn't necessarily the only way of thinking about that problem, but that's how I see it. All right, so this one, guys, we're dealing with our semicircles. An inscribed angle subtends a semicircle if the angle is a right angle. Well, let's think about that. How many degrees are in a semicircle? 180 degrees. So basically, the intercepted arc is going to be 180 degrees, making that half that, which is 90 degrees. Okay? So you could have figured that out without me even telling you this. We're going to use that. Now this is going to be something that you're going to have to use and kind of unpeel those layers in some of these problems. So here we want to find each value. We want to find x. Notice what the question is asking us. This is telling us this is the diameter. Some of you guys had questions about that. You know it's the diameter because it goes through the center. So you can go ahead and assume that. That means this is 180 degrees, which means this is going to be a right angle, which is 90 degrees. So this angle measure equals what? 90 degrees. So just pulling in a couple of different of those layers to solve this problem. All right, there's your equation right there. Solve for x and you get x equals 21. So let's look at a different problem here. All right. This is going to go back to our corollary. I want to find y. Oh no, I don't. I want to find the measure of ADC. Okay, so I need to find y first. Now let's see how we can set up an equation here. I know that this angle subtends this arc. Okay, it intercepts this arc, so this arc subtends this angle. I also know that angle ADC also intercepts that arc. Well, based on the corollary we just talked about, that means that those two guys equal each other, even though they're located on different places of the circle. So 10y minus 28 equals 7y minus 1. Solve for y and you get 9, and then answer the question, guys. All right, I want to find ADC, so I'm going to plug it into 7y minus 1. Of course, it doesn't matter really which one you plug it into, but just to work nice and clean, and you get 62 degrees. Okay. So again, not a lot of calculations. Noticing is the part that can kind of throw us off sometimes. All right, last chunk. Now we're dealing with quadrilaterals. Okay, so if a quadrilateral is inscribed in a circle, all right, the vertices are all on the circle, its opposite angles are supplementary. Okay, so that means that angle A and angle C are going to add up to 180 degrees. And that also means that angle D and angle B are going to add up to 180 degrees. Okay? We'll use this property. So we want to find the angle measures of our quadrilateral PQRS. All right, so I don't know what S is. I know that these guys all up at 360 degrees. Okay, I would maybe explore that. And based on what I know, I also know that these two guys here add up to 180 degrees. They're supplementary. So there's my equation right there. 6y plus 1, okay, parentheses just so you guys can see it, not necessary, plus 10y plus 19 equals 180, okay? Go ahead and tighten everything up, and you get y equals 10. So now, you guys, it says find the angle measures, so all you need to do is go through and plug them in. So we know that the measure of angle P, after plugging that y in, is going to give me 61 degrees. Okay, the measure of angle R is going to give me 119 degrees. The measure of angle Q is going to be 148 degrees. And then we can just figure out S by subtracting this from 360. And you get 32 degrees. Okay. So that's all I got, you guys. Our inscribed angles, we'll work on our homework in class tomorrow, and then we're going to bump it up for the next couple of lessons. Will be a little heavier.